Have you ever tried focusing in a really hot classroom? It's tough. Well, there's a reason for that. And here's how science backs that up. According to the World Health Organization, when it's super hot, thinking, working, and learning become tricky. Extreme heat can even lead to illness and death. Plus, heat isn't great for air quality and can cause issues for health services and infrastructure. So staying cool isn't just about comfort. It's like a superpower for our well-being. When the sun heats up the outside of a building, some of that heat sneaks inside. We call this solar heat gain. When it's hot, more folks crank up their air conditioners at the same time, creating a big demand for electricity. This can increase pollution from power plants, and it might even overload the power system, leading to brownouts or power outages. So how do we handle the heat in our neighborhoods? Well, there are a lot of strategies, but right now let's talk about one cool idea: designing buildings that reflect sunlight away instead of soaking it in. The sun is the main source of energy for our planet. Sunlight reaches the Earth in 3 ways: UV, visible, and infrared rays. When things like roofs or walls absorb these rays, they get super warm and make the air around them hot too. The radiative properties of roofs and walls affect how they take in the sun's energy and can make a big difference in how hot a building gets. We measure a material's radiative properties on a scale from 0 to 1, with 1 being the coolest. It's like giving each material a score to see how cool it stays in the sun. The higher the score, the cooler it is. Let's talk about the first property, called solar reflectance. This radiative property is the amount of sunlight that bounces off a surface. It is the opposite of solar absorptance, which is the amount of sunlight a surface soaks up. Have you ever touched the outside of a dark car and then a light one on a sunny day? The light car probably feels cooler because it's reflecting more sunlight. Next is thermal emittance. This means how good a material is at letting go of heat it's already absorbed. You've probably felt thermal emittance and maybe even used it to warm up on a cool day. Ever wonder why the side of you facing a fire or hot object gets warm while your back is still cool? That's the thermal emittance from the fire or hot object warming your front side up. Want to get your back warm too? Just turn around. How do you think a building's radiative properties can affect the safety and comfort of occupants during hot times? What about AC use? Do you think the color of a surface can affect its radiative properties?